Podcast Bites.
I combine this intense time in the trenches with a blend of ancestral wisdom and modern science, searched the globe for the world's top experts in performance, fat loss, recovery, hormones, brain, beauty, and brawn to deliver you this podcast. Everything you need to know to live an adventurous, joyful, and fulfilling life. My name is Ben Greenfield.
It's important to understand where fat actually goes, like how fat actually gets burnt, because most fat loss books and so-called weight loss experts and physicians and dietitians and personal trainers, they'll tell you that fat is converted to energy or is converted to heat, but that actually violates a law called the law of conservation of mass. And all that law states is that mass in an isolated system is neither created nor destroyed by chemical reactions or physical transformations. So in other words, you can't simply take fat and poop it out or turn it into muscle. Instead, the primary place that fat goes when you lose weight is your breath. You breathe away fat. Your lungs are the primary excretory organs for weight loss. So any excess calories that you eat, here's how it works, including carbohydrates, protein, and even that, a half stick of butter that you put into your green tea or coffee, that gets converted into triglycerides, which is a type of fatty acid. Now, excess carbohydrate or protein is converted to triglyceride and stored in the lipid droplets of fat cells. Fat cells are called adipocytes. And excess dietary fat then undergoes something called lipolysis, or the breakdown of fat, followed by another process called reesterification to allow that fat to be stored. So people who want to lose weight while maintaining muscle and other important tissue are, biochemically speaking, trying to burn through triglycerides that are stored in adipocytes, lipid droplets that are stored in, or triglycerides that are stored in the lipid droplets of fat cells. Now, triglycerides are comprised of three types of atoms: carbon, hydrogen, and oxygen. And they can only be broken down when these atoms are unlocked through a process called oxidation. And that requires, this is where breath comes in, the inhalation of oxygen. So there was actually a research study that was done. It was called When Somebody Loses Weight, Where Does the Fat Go? Great title for a research study. And what the researchers found was that for 22 pounds of fat to be oxidized, 64 pounds of oxygen must be inhaled. And the oxidation results in about 61 pounds of carbon dioxide excreted via the lungs and about 24 pounds of water excreted via urine and feces and breath and sweat. So your lungs are the primary excretory organs for fat loss. Now stick with me here on the math. So every breath that you breathe out contains a little over 0.001 ounces of CO2. And about 0.003 ounces, or rather 0.0003 ounces of that is carbon. So an average total of 17,000 breaths during the day is going to get rid of around 0.32 pounds of carbon. And about a third of that fat loss is occurring when you're doing nothing at all, like when you're sleeping during the night. So how do you replace all that carbon that you breathe off? Well, unless you're eating charcoal rocks or overdosing on charcoal capsules, the only significant carbon sources that I personally know of are dietary carbohydrates, proteins, and fats. So from as simplistic a standpoint as possible, losing fat means consuming less carbon than you've exhaled. So if you were to spend a day asleep, at rest, and performing light activities that honestly can nearly double your resting metabolic rate, just walking around and moving, you'd exhale about 7 ounces of carbon. By substituting 1 hour of rest per day with 1 hour of moderate exercise, like going on a hike, riding a bike, doing some weightlifting, your metabolic rate is increased by about 7-fold. And that removes an extra 1.5 ounces of carbon from the body, increasing the amount of carbon you exhale by around 20%, from 7 ounces up to 8.5 ounces. Now, the problem is all that carbon loss can, of course, be offset by eating carbon molecules from carbohydrates or protein or fat. So, a single 100-gram whole wheat muffin, for example, will give you about 20% of your average daily energy requirement. And that means physical activity as a weight loss strategy is foiled even by relatively small quantities of food. And so the most effective, albeit traditional and boring solution to this conundrum that does not sell many supplements and it doesn't sell many diet books and it doesn't sell many biohacks or anything else is to simply move more and eat less. Now, that's it. You know more about the true mechanisms behind weight loss now than the average biochemistry student. The problem is, let's say you're already eating less and moving more. You're theoretically now engaging in enough physical activity to breathe off more than enough carbon, and the scale still isn't budging. So what gives? Well, that's what I want to dig into in this podcast. But I had to lay it out beginning with this explanation of how you breathe away carbon so that you know that from a very simplistic model, the lowest hanging fruit, the bottom of the totem pole or the top of the totem pole, depending on how you want to think about it, is that you must be ruthlessly cognizant of carbons in and carbons out, how much you're moving and how much you're eating. Okay, so that's the number one thing that you need to pay attention to.
Avocado, motherfucker.